So we're going to continue looking at moments of inertia of rigid bodies today. And what we're going to start with is some arbitrary shaped object. And what I've drawn here is a set of coordinate axes, x, y, z. And I have some arbitrary rotation axis. So this is the rotation vector omega. And we want to start by going back to the simple expression for the moment of inertia for rotation about this axis. So I'm not going to work out the tensor itself. I'm just going to work out what would be the moment of inertia for the rotation about this axis. So I will consider some mass point here, which I will label as m sub I. So this is my mass point. And from the definition, what I need is that perpendicular distance to the axis. So I'm going to label that as Ri. And then from the origin, I have a vector little ri. So the moment of inertia for this mass point for rotation about that axis, and I'll write this just as IN. Of course, I would have to sum over all of these individual mass points, mi, and then it's this perpendicular distance squared. So that's for the moment of inertia for rotation about that axis. It's just a single number. I'm not working out the full tensor. I'm just looking at that single number. I can express this perpendicular distance as, so Ri is Ri sine theta, and so this is my angle theta here between this axis and that vector. And I take a unit normal vector, and then I can express this quantity as Ri cross n. And so now my moment of inertia is a sum over I of mi, and it's Ri cross n squared. So I'll work out what this cross product is using the determinant form. So I, j, k, xi, yi, zi. And then I need to work out basically what the angles are between these things. And I can use the direction cosines. So my vector omega I can write as the magnitude of omega into omega x over omega, omega y over omega, and omega z over omega. So these are just the individual components. And I can then replace these with the direction cosines. So I'll call that cos alpha, cos beta, and cosine gamma. So these I insert cos alpha, cos beta, cos gamma, and I take my determinant, and that will give me the cross product. So then we have to work this out, take the square, and then see where that will lead us.